Hello viewers right there, welcome to IO Code. IO Code is a YouTube channel where I post program related content. This is the very first video of a series that I titled The Weekend Algorithm. Now the weekend algorithm is all about looking for an algorithmic problem, trying to come up with the possible best solution to solve that particular problem. Now these questions are questions I'll be getting from different coding platforms as random, and then I'll just try to solve it, show you the algorithm I came up with, and probably you can learn a thing or two from this video. Now this very first video we'll be looking at a kind of tricky problem. It's easy to solve, but at first it kind of seemed difficult. It took me some time to solve when I started programming, when I got introduced to the platform. But with constant practice, I discovered new ways to kind of find solutions to different problems. Now the question goes like this: a city has n tram stations numbered from 1 to n that are connected to one another and form a circle. They are given an array ticket cost, where ticket cost at index I is the cost of a ticket between the stop number I and I plus 1 mod n. Now remember that n is a number of tram stations, and the tram can travel in both directions. So this is where the tricky thing comes into play. So the tram can travel in both directions, both clockwise and anti-clockwise. Now you have to return the minimum cost to travel between the given start and finish. So what this implies is that you have to calculate the cost it takes to travel in the clockwise direction from the start position to the end position, and calculate the cost it takes to travel from the anti-clockwise direction, that's to travel in the anti-clockwise direction from the start position to the finish position also. And then you have to return the minimum cost between these two. You have to compare the cost to travel in the clockwise direction and the cost to travel in the anti-clockwise direction, and then you have to return the minimum between the two. Now you are given, these are the sample data, the way you are given data. You are given an integer n, where n represents the total number of tram stations. That is to say, for each tram station, recall that there is a price between this tram station and the next. So this would be the length of our array. The total number of tram stations, an integer start, which represents the start station, and an integer finish, which represents the finish station. You are given an array of positive integers. Now ticket cost, where ticket cost I represents the ticket cost between station number I and I plus 1 mod n. Now you have to determine the minimum cost to travel between the given start and finish station. This is the task. So the assumption is here. So n is equal to 4, the number of tram stations. The start station is the very first station, and the finish station is the first station. Now look at your approach. From here we get the approach. Now from the very first station to the second station we have value 1. From the second station to the third station we have a cost of 2, and moving from the third station to the fourth station we have ticket cost of 2. So we sum all of this together and we have the value of 5. Now for the part 2, which is the backward direction, so we'll move directly from tram station 1 to tram station 4, and the cost is just $4. Let me say dollar. No, they didn't really specify any particular currency, but I'll just use the dollar in this case. So we have value of 4. You can see the kind of explanation given is quite not explanatory in itself, because we have 4 and we have 4, so it's kind of confusing. And we also have 1 right here, trying to say, okay, this is the first station and this is the first station, but no, that's not it. So that's why I personally came up with this diagram. So this is the best I could come up with. Now specify the station number. So this is the first station, this is the second station, and third and fourth station. So we can see that this station is in a circular path. So the first station is connected to the first station, and the fourth station is also connected to the third station. Now the cost it takes for each station can be seen at this other part. So we have 1, 2, 2 and 4. So moving forward, so my arrow is just showing backward, but moving forward from first station to second station, we pay a cost of $1, and moving from second station to third station, we pay a cost of $2, and moving from the third station to the fourth station, we pay the same cost of $2. Now if we are to sum the cost it takes to move in this forward direction, that's the clockwise direction, we will see that we pay 1 plus 2 plus 2, which will sum up to $5 just to move from this first station to the fourth station. Now to move from the first station to the fourth station in the anti-clockwise direction, all we have to pay is the value of $4. So comparing these two, we have 5 for the clockwise direction and 4 for the anti-clockwise direction. We are going to return the minimum value, and in this case the minimum value is 4. So that's just what we got from our sample data. Now let's see another example. If we are to travel between the first station and the third station, what will be the minimum cost? The minimum cost will be 3. The reason for that is because when we sum the cost it takes from station 1 to 2 and station 2 to 3, you can see that our value is 3, but the cost it takes to move in the reverse direction, that's the anti-clockwise direction, from station 1 to 4 and then station 4 to 3 is 4 plus 2, which is 6. So we are going to return the minimum value, and in this case the minimum value is 3, and it's in the forward direction. So I've written the code already. All I just have to do is show you how I implemented it. So I'll open my IntelliJ. Just to let you know, I made use of IntelliJ because that editor on the screen is quite difficult for me. I have to complete stuff. Sometimes the editor don't really function the way I want, but I just copied what was on the editor right there. As I copied everything from here, and then I created the same class in my IntelliJ, and I pasted everything on that code editor right here. So we can see that we have our public static void main, and yes, our scanner class is used to get data from the input. Now we have to get the number of stations. The number of stations should be the length of our array ticket cost. So the number of stations, as was explained previously, is the very first data we'll be getting from the sample data. So we have to get the values using our scanner class, our scanner object, and we also have to get the value of start and the value of finish. Now we use the for each loop. We create our array for ticket cost, and we use the for each loop to populate the array. So at index 0, our ticket cost should be the very first value in the series, and our ticket cost length, the last index for I, should be less than the length of the ticket cost. The reason is because of index out of bound exception. We start accessing array values from 0 to the length of the array minus 1. We can't access the value in the length of the array. You understand what I mean? I believe so. Now we use the for each loop to populate our array. Now we then move forward to calculate the minimum cost by just equating this method. We'll be looking at how to implement the method in the next phase. So then we'll just print out the minimum cost. So this is what is inside of our main method. Then in our solve method, which is the method we have to complete in the code editor that was given in hackerearth, we have to implement this. Recall that the question is kind of tricky because the tram can move both directions. So don't expect your start position to always be less than your finish position. So I made this little check at first. So if the finish position is less than the start position, make the start equal to the finish position. And okay, sorry, I can see there is an error here. Let me see. At first, int 10 equals to start. So finish should be equal to 10. So that is programming for you. Sometimes we make some little error. So I decided to switch the values from the start to, if the finish value is less than that of the start value, I decided to exchange their values. So for that we need a temporary variable. So this temporary variable is going to hold the start initially, and then we equate the start to the finish value, and then we equate the finish value to the temporary value. Now, just to make things easy and simple, I decided to make use of the stream API. I used array.stream to calculate the total sum of all the values in the array. Now this is kind of why I implemented it this way, is because we don't have to define two for each loop for the start and the finish. So we have to calculate the total cost it takes, the total cost of all values in the array. Now when we move in the forward direction and subtract the cost it takes to move in the forward direction from the total cost, from the total sum cost of the array, we'll get the cost it takes to move in the backward direction. Just want you to think about it in the form that we have on the given array. From the picture, I'll put it up. We have this given array 1 plus 2 plus 2 plus 4, and altogether the value is 9. Now to move from station 1 to station 4, the cost is 5 in the forward direction. So we subtract 5 from 9 and we get the value of 4. So we can see that since to move in the forward direction is 5, and we then subtract it from the total cost of moving all through the part, that is to complete the circular part, then we get the value it takes to move in the other direction. I'll go once again. Now the total cost of all the values in the array is 9, and the total cost it takes to move in the forward direction is 5. So all we have to do is say 9 minus 5 to get the value it takes to move in the other direction. So in that case it's 4. And we can also implement the same thing by saying the total cost it takes to move in from station 1 to 3, the minimum cost, is 9 minus 3. And we compare 6 to 3, and we can see that 3 is indeed the minimum value, like I explained earlier. So that is how I came about this algorithm. That is how I came about this solution. So this kind of like the fastest. You don't have to start defining for each loop and checking if it has gotten to the end index and then start over again. So that's cancel. Now we have to specify our value for long cost. We have to initialize, then the cost it takes to move from the start to finish position, we have to calculate for it, and then we compare if the sum cost minus cost is less than cost. We have to say cost is equal to sum cost minus cost. S just return cost. So after this if condition is checked, it returns cost. So no matter what, our value remains on the minimum, and then we print out the minimum cost from this position. So I run the program, or I'll just copy everything, Ctrl C, and I bet this should be my first page in the platform for this channel. And yes, I'll compile and test my code. Hold on a bit, it's evaluating. Okay, sample test cases passed. So output was 3 and the expected corrected output was 3 also. So I'll submit the code now. Oh, it was partially accepted. Where is that? Okay. I saw where I made a little error. It was a little mistake. The issue was that I changed something along the line when I copied everything from this editor to my IntelliJ editor. What I did was change the initial type of the array from long to int, and that was an error on my part. So that was what really made the result partially accepted. But as you can see, the last result was what I didn't really get any score for. So what I did change the type of the array to long, and then we'll compile and test our code again. It's evaluating. Okay, as you can see, sample test case passed, and I'll have to submit the code this time around. Now status are changed from partially accepted to accepted. So that is the algorithm I implemented while solving this problem, and the total time it took in seconds for it was 1.24 approximately, and this is the total memory in kilobyte. So thanks for watching, and I'd love to see you in the next one. And there will be a short video attached to this particular video, just showing the algorithm step by step. If you can watch this long video from beginning to the ending, please do refer to the other video that shows the algorithm. Thanks for watching. Peace out. I'll catch you in the next one.